name's Sherin. I'm a second-year master's student in CSE. I'm going to be talking about data structures today for EECS280 class. First off, we want to know what data structures are and why do we need them. Data structures are just containers for data that we want to organize in the computer memory. We have a lot of these, including arrays, lists, queues, stacks, heaps, trees, graphs, hash tables, and so on. This can go on and on. We need them because they immediately affect the performance of the program that we want to do. And that, of course, depends on the different tasks that we want to accomplish. And so here, for example, a tree is different than a queue, is different than a list. The complexity, the time complexity and space complexity are totally different. So, for example, what is the queue? Before I even talk about it, imagine a queue of people lining up at a supermarket in order to pay. So the first person will be served first, and not the one in the middle, not the one in the back. So it's like first in, first out kind of concept. Here, this queue has a beginning, front, and has an end, which we call it back array of the queue. We also have the stack, which is the contrary of that. It's a LIFO-based. It's last in, first out. Anyways, we have only also the tree. It's a binary tree, for example, here. It is called binary because each node, we call this a node, which holds the data, can only have 2 children. The first node, which has no parents, as you can see, we call it the root, and the last set of nodes, we call them the leaf nodes. And these all pointers line up to form this tree. For example, each node has a left and a right pointer, and so on. When it comes to choosing between the two, we want to know which one to choose. For example, if we send a query to print documents for a printer, it's FIFO, it's first in, first out, so we know that we gotta use a queue. For the next set of slides, if we want to, for example, search an array to do an array search, so we want to see like which. So here, for example, we put the less. Here's the median of the array. Here we put like the items that are less than the median, or the items that are greater than the median. And so when we know, oh, I want a value that is greater than this, I don't need to traverse this site, and that greatly reduces my time. More data structures to talk about. Lists. What is a list? A list is an ordered set of data that is, we use it for storing objects that are sequential. Well, each list can be thought of as a queue too, but not the other way around. For example, like this is a list of dancers. So if one of them falls, like let's say if one of them falls, the others fall because like they're all connected to each other. Wherein an array is an index set of variables that, for example, index at position 1, index at dancer at position 1, dancer at position 2, dancer at position 3, and so on. So each position holds one data item. Okay, so let's compare the two. The main basic comparison that I'm going to be using here is, let's say we want to delete an item. If we delete an item from the list, let's say we deleted the red dancer here, the others automatically point to the next one. So like the blue dancer would point to the green one. Wherein in an array, if we delete the red dancer, that position that used to hold it is now empty. So the missing spot is filled with something's deleted in the list, and that's not going to happen there. Okay, yep, the empty variable is left behind. Thank you for watching.